This is Abdul Khader from Karnataka Polytechnic, Mangalore. I welcome you all to my next class on industrial management. Currently, we are discussing Unit 2, that is production management. This is the third and final class of Unit 2. Let's have a quick look of what we have discussed in our previous classes. In the first class, we discussed the concept of project and various characteristics of a project. We went on to discuss the functions of a project, and then we discussed various issues related to site selection. Finally, we discussed plant layout. We classified plant layout into different types of layout and discussed the relative merits and demerits of each of the type. In our second class, we started our discussion with production. We classified production into different production systems, and we discussed each of the production system. Then we went on to discuss the productivity and the factors affecting productivity. Finally, we discussed the impact of the productivity on our society. Let us now have a quick look on the content of our today's presentation. We will start with the concept of production planning and control, popularly known as PPC. We will discuss the major functions of PPC. Then we will discuss two tools for production management. One is critical path method, CPM, and the other is program evaluation review technique. Let's now have a quick look on the content of our today's presentation. We will start with the concept of production planning and control, popularly known as PPC. We will discuss the major functions of PPC. Then we will discuss two tools for production management. One is critical path method, CPM, and the other is program evaluation review technique, Pert. Then we'll have an interactive quiz where you can select the questions and answer them. Let us start with production planning and control. If you come to Mangalore bus stand and ask where is Karnataka Polytechnic, probably you may not get a proper answer. Many of them may not be knowing where is Karnataka Polytechnic. But on the other hand, if you ask where is KPT, everybody knows. That is, many times the abbreviation is more popular than the actual name. That applies to production planning and control also. PPC is the common abbreviation for production planning and control. Let us now understand the concept of PPC. Let us define PPC first. The PPC is the process of planning the process in advance, setting the exact route which the product will pass through the industry while being converted from raw material to the finished product, and then setting the starting date and the ending date for each of the item, giving production orders to start the production activities, and finally do the follow-up action once the production activities have started to ensure that the production is going on as per the plan. So we can define PPC as the process of planning the process in advance, setting exact route for each item, setting the starting and ending dates for each of the item, and then giving the production orders to the shops, and finally to follow up the production according to the orders. Let us first list the functions of PPC. The first function is planning. That comes right at the beginning of PPC. That is a basis for all further work of the PPC. We need to plan and then start the work. Routing is fixing the exact route which a component has to pass through the industry. Then comes scheduling function. That's about fixing a timetable for manufacturing activities. That is fixing a start date and end date for each of the products. Then the dispatching, which means authorizing people to start the production activities, giving them the necessary powers to act on them. And finally, to the follow-up activities once the production has started. In the end, the inspection function comes, which is a determinative function to decide whether the quality is acceptable or not. Let us come to planning. Do we plan always? Yes, we always plan. Not planning is also a way of planning. That is deciding not to plan. Either we plan for success, or by not planning, we plan to fail by default. So there is always a plan. The question is whether there is a good plan or not. In a broad sense, planning means thinking before doing. We make a plan either mentally or in written form for our activities. This is nothing but planning. In an industrial scenario, planning means deciding the overall manufacturing process for producing a component. Planning involves a number of activities. Designing a product comes at the beginning, and then determining the necessary equipments and the capacity of production. That involves planning. Then comes the material handling. That's also the part of planning. Then deciding the nature of operations and the sequence of operations. That involves elaborate planning. Then we have to calculate the time requirement and the labor requirement for the work. That's essential component of planning. Finally, specifying the quantity standards as well as quality standard is also part of planning. Planning involves deciding all these things about the production in advance before the production starts. Routing is the next function. Let us take the example of bus. In Mangalore, from State Bank to KPT, buses come through different routes. The one bus comes one route and they've given a number for that route, it's 19. Another bus comes through a different route, they call it 14. There's also another 14A. So what does it mean is that the buses will start from State Bank, it will reach the KPT, but through different routes. Similarly, a component will enter the production process as a raw material and finally go out as a finished product. The path traced by the component within the industry is what is known as the routing. So routing is the selection of path which the product will take while being converted from raw material to the finished product. Routing essentially decides 5 things. It will tell about the operations which are performed. The routing will tell about the path of flow of the component. Routing will tell about the sequence of operations. Also, the machines used will be indicated. In addition, the routing will also tell the operators which are required for the operations. The routing is the process of deciding all these questions. Let us come to scheduling. I said the routing tells, in our bus example, from State Bank to KPT, it comes through a different route. But that is not useful to me unless I know when the buses will come. That is, in addition to routing, we need to fix the starting and ending time for each of the operations. So that is what is known as the scheduling, the fixing, the starting and finishing dates for the processes. That means the routing and scheduling together will give you the total picture of the manufacturing process. Basically, there are two types of schedules. One is known as a master schedule, other one is known as a part schedule. Let us now discuss both of these schedules in detail. Let us first look into master schedule. Master schedule uses a bird eye view of the manufacturing process. Whenever orders are received, they are first accommodated in the master schedule. That means the master schedule gives the starting and ending time for all the items which the organization produces for a specific future period, say 6 months or 1 year. Part schedule is prepared after master schedule. The part schedule is the breakup of the master schedule. That is, the part schedule is with respect to one part or one department, but this will be more elaborate and more detailed than the master schedule. Let's now have a look at a tool for scheduling, what is known as a Gantt chart. This Gantt chart gives the start and end time for the activities. Let us take one software design activity. So initial design of the software takes 45 days. So it will start in January. It will come almost near April. Then the second activity, it will start once the first activity is completed. That will take the next 20 days. Next comes designing a parser. That will be completed after the previous activity is completed. That will take 60 days. Next is code generator. But what you need to know is that it starts well in advance. It runs parallelly with other activities. Next is the writing manual. It starts at a particular stage. The code generator is going on, and along with that, the writing manual also starts. Then integration testing, it is not done at the end. Parallelly, along with the writing manual, along with the code generation, the testing and integration is also done. Finally, a finish date comes there. That means this is the start date, this is the finished date, and what are the time taken by different activity is represented in the form of a chart. This is what is known as a Gantt chart. It's just an example of a Gantt chart. Let us come to the next function, that is dispatching. Dispatching is an implementation function. Till this stage, nothing is done. Everything is on paper. The route sheets are on paper. The schedules are on paper. This is the implementation function which starts the production processes. That is, the production process keep rolling once the dispatching function is done. So dispatching function gives necessary powers to every person to execute as per the plan. It authorizes the departments to draw material from the stores. It authorizes them to draw material tools from the tool section, and it gives the orders for the inspection staff. That means everybody gets their necessary power after dispatching. That is, dispatching gives authority to different people to execute the work and take whatever steps are necessary for executing the work. There are two types of dispatching. One is called the centralized dispatching, where the PPC department itself issues all the dispatching orders. That means all the dispatching is done from a central point. Then we have got the decentralized dispatching, where the PPC gives orders to the different departments and they in turn do their internal coordination and further dispatching work. That means it's a decentralized in the sense that each department will do its own coordination work and its own the work distribution independently. Let us now discuss the functions of dispatching. The dispatching authorizes the movement of materials from the stores. Dispatching authorizes to take up the work on hand. Dispatching gives inspection orders. Dispatching authorizes the tool sections to issue tools. That means all the related sections are given necessary authority to execute their work by the dispatching order. Dispatching function keeps the production process rolling. Next comes the follow-up function. Follow-up function is the control process to ensure that the work is going on as per the plan. It is a process of monitoring the actual work to ensure that it is going on as per the requirements. Let us quickly look into the functions of the follow-up. One of the functions is to report the daily progress. That means there will be the sheets for each shift. So the progress of the work is written in specified formats. Basically, the function of follow-up is to ensure that the work is going on as per the planned schedule. If it is going on as per the planned schedule, there is no need to do anything except keeping an eye on the process. If at all there is the delays and problems, the next work is to investigate the causes. Why is the delay happening? Why is the plan not going on as per the plan? This analysis is to be done as part of the follow-up. After the analysis, there may be certain causes which are identified. The corrective actions are to be taken to address the causes, to address the problem so that the production is brought back on rails. And also to get the feedback information about any difficulties, any problems, any issues with respect to the production. These are the broad functions of follow-up. Let us now come to inspection. In Ramayana, you might have read the story of Shabari. She waited for Rama and she wanted to give Rama the sweetest possible apple. So she collected the apples in a basket. She took a bite of each of the apple to make sure that they are sweet. So she separated the apples from the sour apple and kept only the sweet apple to be given to Rama. What she is actually doing was the inspection. She was separating the sour apple from sweet apple by the process of inspection. So what is inspection? The inspection is defined as a process of measuring the quality of a product or a service against established standards. That means we have got specifications. The quality is to be measured and compared with the established standards or specifications. Inspection is essentially a determinative function. It is a binary function. It will give either yes or no. It will not give half yes or half no. If you take your semester examination, it will give a marks card whether it pass or fail. It will not tell half pass or half fail. Or if you look at the lamp, either it is on or it is off. The inspection is also like that. It will give whether yes or no. Let us now look into the broad differences between inspection and quality control. There are two major differences. One is with respect to the very objective itself. The objective of quality control to ensure that the defective items are not at all produced. On the other hand, the objective of inspection is to ensure that defective products do not reach the customers even if they are produced. That means with respect to the scope, the objective is broad with respect to the quality control. That is what scope. The scope of quality control is much wide compared to the scope of the inspection. In fact, the inspection is also part of quality control. Let us now look into the objectives of the inspection. The first objective is to collect information about the performance of the product from different sources, including the different customers. That means the inspection will collect the information about the product and it will do everything to maintain the quality. That means whatever steps are necessary to be taken for maintaining quality, that is the object of inspection. And how inspection is to be done, that itself is a question. The necessary inspection standards are to be devised for proper inspection. Inspection is a very sophisticated job. We need precision equipments for doing inspection. That means the equipping the inspection department with the most advanced, the precision equipment is another objective of inspection. Whenever the new methods and new machines come, people also need the training to operate them. That means the training, the inspection staff is also another objective of the inspection. And finally, doing all the above things, what we want to do is sort out poor quality products from the good products, and then some of the things may be rejected. So what is to be done with the rejection? That is rehabilitation of the defective part is also another objective of inspection. Let us now discuss the different types of inspection. One inspection is what is known as the patrol inspection or floor inspection, where the inspector moves from machine to machine. He does the inspection work near the worker himself and he decides whether the quality is good or not. This is a fast method of inspection. It has got certain strength. First of all, here the errors are quickly detected. Then when the inspector moves, he'll be knowing where error is taking place. Immediately he gives an instruction to correct the errors. In addition, the work will not pile up near the machine. As and when production is going on, the inspector will go there, inspect and clear the workpieces from near the machine. So the workpiece will not become clumsy and cluttered in this type of inspection. In addition, the worker can get guidance from the inspector about the causes of any error, if any. And there are also the disadvantages of floor inspection. First of all, the highly sophisticated machines cannot be used on the shop floor. That means he has to manage with the general purpose machines, which may not be very accurate method of inspection. Another big problem is that the personal biases and the may arise. There may be arguments, and there may be the relation problems between the worker and the inspector that may adversely affect the inspection. That means personal bias plays a major part in a patrol inspection, which will not play such a part in a central room inspection. The other type of inspection, what is known as central room inspection. In a central room inspection, all the workpieces are carried to the central room and inspection is done there using sophisticated machines and equipments, and for the next stage of work it is brought back to the shop floor. Here the obvious advantage is that the more advanced, more sophisticated the machines and tools can be used for inspection, which cannot be used on the shop floor, then the personal bias will not play a part here, because the inspector will not be knowing who has manufactured that. On a merit, he will be deciding the components as acceptable or not. But there are two major drawbacks with this system. One is that it will take a lot of additional handling. The materials are to be carried from the shop floor to the central room and brought back for the next level of processing. And before being transferred, these materials will be near the machine itself, waiting for transport. This will make the shop floor clumsy. Another problem with this inspection is that it will take, the errors are not caught on time. After the entire shift has finished the work, all the materials are transferred to the central room, and there, if it's any error is detected, it is too late to correct the errors. Then there is another type of inspection, which is what is known as a 100% inspection. 100% inspection means all the items are inspected. Each and every component is inspected and tested, okay or not okay. But we need to remember that the 100% inspection will also not give 100% result. It gives only, say, 90% result. That is because the human fatigue and human error, human beings cannot work like machines. Because of the human fatigue and error, even 100% inspection will not give 100% results. Many times, the sampling inspection gives better result than 100% inspection. In sampling, what we do is we draw a sample from the whole lot. We inspect the sample and then interpret the result to the total lots. That is, if there is a huge number of boards produced, well, a small number of boards are taken out, inspected, and the result of that inspection is interpreted for the entire lot. Also, we need to remember that sometimes we go for the destructive test. In a destructive test, 100% inspection means 100% destruction. There we can only go for sampling inspection. We can only take a sample of the total products. We can inspect that. For example, if you take chocolates, if I had to go for 100% inspection of the chocolates, I'll have to eat all the 100% chocolates. There will not be nothing left for selling. So many times it is not possible to go for 100% inspection. The sampling is the only option, but the experience says that many times sampling gives better result than the 100% inspection. The tool inspection is based on the assumption that if the tools are right, the product is going to be okay. That is, you inspect the tool, and based on the tool, you decide the product is acceptable or not. The functional inspection is another type of inspection where the end inspection is done, the end, to see whether the product is doing its intended function or not. That is done after production, after assembly, by looking at how does the product works. The operation inspection is done at different stages of operation within the organization. So one operation is going on, inspection, then after next operation, again inspection. That means after each and every stage of operation, inspection is carried out. That is what is known as the operation inspection. The final inspection means at the end, after all operations are carried out, you inspect the product and decide whether it's okay or not, whether it's acceptable or not. The pilot piece operation, the inspection is one inspection which is primarily used for an automated plant, where after setting all the machine and tools in order, the first or a few pieces are passed as pilot pieces. If the pilot pieces they are all right, the production line is open for production, and usually it gives the same result as the pilot product. Then there is one inspection, which is key operation inspection. That is, some operations are difficult, where the operators are more likely to make errors. Some of the operations are easy. So we need to do the inspection only after the key operation. If the key operation is done well, other operations are much simple. They need not do. For example, in a mathematics, if a person knows how to divide, we don't have to ask whether he knows how to add or subtract. When we know when he knows a complex operation, simpler operations understood. That is, only key operations are inspected, and other operations need not be inspected. The last type of operation is endurance operation. This is how long the product will last. For example, the projector bulb is a costly item. How many hours it can survive its working? That is, we will have to switch on the bulb under the conditions, the voltage, and then go on seeing how long does it last. That is endurance. That applies to all the products. Every product takes the load, but someday or the other that fails. But how long it can take the load and how long it can survive, that is what is known as the endurance inspection. Let us now move on to discuss the two tools of production planning and control. First, let us discuss critical path method. Critical path method is nothing but a management technique which tells us how best to reduce the time required to perform the routine production maintenance operations. That is, how to reduce the direct and indirect expenses by saving time. That is the objective of critical path method. Two terms are critical in using the critical path method. The first one is what is known as an activity. An activity, it refers to any task that consumes resources. When I say resources, I mean time, manpower, space, material, money, or anything of value. That means an activity refers to a task that consumes resources. A project will consist of a number of activities in a particular sequence. When all activities are completed, then only the project is said to be complete. That means each and every activity has to be completed for the project to complete. Activity is nothing but the completion of a task. That means we need to know that activity is a task which takes resources. Let us come to the second term, that is the event. The event is either a start point or end completion of a task. That means it is not a task, it is an instantaneous point in time in which something happens to the task. So that means this event is either a start of a work, end of a work, or a critical point during the work. But we need to remember that as this is not the task, this does not consume any resource. Let us take an example. A machine installation is an activity. It will take the resources. On the other hand, start of machine installation and completion of machine installation are just 2 points in the operation. They are the two instantaneous points of time. They are known as the events. That is, installation itself was an activity, but the start of installation and the end of installation, they are the events. Let's now discuss the critical path method, CPM. We'll take an activity, a construction work, in which certain operations are done in sequence. The first activity is plastering the ground floor. Then comes the plastering the first floor. This is the next activity. Next activity is with respect to the painting. The first thing is to select the paint. Next is the order for the paint. Next, test the paint. then paint the ground floor, then paint the first floor. This gives a sequence of operations. Let us now take another related example. Here, say the collection, the selection of color of the paint, then order paint, then paint testing, then test the ground floor, and parallelly another work is done, that is plastering the first floor. That means these two are done parallel, they are not independent. But for this to be done, it has to be completed. And after this, the plastering of the first floor is done, then the plastering, painting of the first floor is done. So this is another example where certain parallel operations are done. Let us now discuss some of the important features of the network diagram as per the CPM. Here I have taken another example where the tasks are shown in this is the start point, this is the end point, and various operations are done in between. So this is the task shown in boxes. Let us see some of the important aspects. The first one is the task. The arrows show the dependent disease. That is, task 3 cannot be completed unless task 1 is completed and task 2 is completed. That means for task 3 to be completed, both task 1 as well as task 2 must be completed. That means task 3 cannot begin until these two things are completed. Task 4 is a predecessor to task 5 and a successor to task 3. That is, this task 4 is a predecessor to this activity and a successor to this activity. So there is both a start point and end point for a CPM. There are certain important things to remember. The first one is that the length of the arrow does not bear any relation to the time taken. That means this length of this arrow does not show any indication about how much time is consumed by that. The arrow indicates only the logical relationship dependency, that is, to start which activity, what activity are to be completed, that is, which activity depend logically on which activity, that is shown by the arrows. The direction of the arrow shows the direction of the flow of work. That means after this, this is done. After this, this is done. So direction of the arrow shows the direction of the workflow. The networks are constructed on logical dependency. That's what we just discussed. And no event can be reached until the immediately preceding activity is completed. That is, we cannot reach this activity unless this is completed. We cannot reach this activity until this is completed as well as this is completed. Finally, every activity is to be completed for completion of the project. That means all these activities are to be completed, then only the project is said to be complete. And no activity can be in a circular loop. For example, I cannot draw something like this. From here, here, here. This is a circular loop. That means there is a never-ending loop. There cannot be a circular loop in a network diagram. We'll come to the advantages of CPM. The first advantage is that it helps us to make a time schedule for the activities. It is a control device for controlling and seeing whether the activities are going on as per the plan. They're consuming the required amount of the time, that is as per the plan. And it makes the detailed planning possible. Based on the CPM diagram, we can plan a detailed about the operation. It allows us to proceed in a disciplined way. That means the activity is logically related to other activities. We can proceed in a disciplined way with respect to all activities. This is a standard method of communicating between different people. That means there are a number of people are involved in a project. We need some common way of communicating between them about the status of the project, about the works which is completed, and about the works which are to be done with respect to the project, its schedules, its cost. So this communication is done better by using a CPM. And it also identifies the most critical elements. What are the more critical elements, what are the most important elements in the process are identified by a CPM. Let's now move on to program evaluation and review technique, what is known as Pert. The Pert is a technique of scheduling the activities where the project involves considerable uncertainties. Some of the projects may not move as per our plan. There is a high level of uncertainties. For such the projects, instead of CPM, the Pert is more appropriate. CPM gives only one time estimate. On the other hand, the Pert gives 3 different time estimates. Let us see what are these 3 time estimates. We'll first discuss the differences between the CPM and Pert. The CPM is an activity-oriented technique, whereas the Pert is an event-oriented technique. CPM has got 1 time estimate. The Pert has got 3 time estimates. Now let us see what are these 3 time estimates. As per the Pert, we have to make 3 time estimates for any work. That is, the one is the most optimistic time. If everything goes well as per our plan, if everything goes as per our the planning, then it will take the minimum amount of time. That is the most optimistic time, assuming that everything will go as per our plan. Second is the most likely. The things rarely go as per our plan. That means there are a lot of uncertainties. So we can say that it will take a little more than the optimistic. That is the most likely time. And the third one is the pessimistic time, where we assume that everything goes wrong. If everything goes wrong, how much time it will take? These are the 3 timings. Optimistic time will be the shortest one, assuming that everything goes very, very well. Most likely time is the most practical. The time is assuming that some of the things go well, some of the things may not go well. The pessimistic time is a time estimate which assumes that everything will go wrong, and in the worst possible scenario, how much time will be taken. Let's make a quick revision of the 3 time estimate. First, we discussed optimistic time estimate, which assumes that everything will go well. What is the time required? This is a minimum possible time. Second is the most likely time. Here, we assume a normal way of working where some things will go wrong, there will be delays, there will be setbacks, there may be some problems. In a normal course of events, what is the time which may be taken? And the third time is the worst possible time estimate. If many things go wrong, if the work proceeds very badly, what is going to be time? What is the maximum time that we may have to take for completion of the work? These are the 3 time estimates as per the Pert. This diagram shows an example of Pert. Different activities are numbered here. This is the activity A, that is the foundation. This is the activity B, that is the superstructure. This is activity C, that is roofing. This is activity D, that is plastering. Likewise, all the activities are listed. Now, this arrow shows the logical dependency as in the CPM, but what is important is that we have listed 3 times. This is the most optimistic time. This is the most likely time. This is a pessimistic time. That means foundation. If everything goes well, we may be able to start in finish in 7 days. If normal 8 days, in the worst possible scenario, we may take 12 days. Similarly, for a superstructure, under the best conditions, we may take 18 days. Under normal conditions, we may take 20 days. Under the worst conditions, we can take 24 days. That means for each of the activities, the 3 time estimates are calculated, and based on that, for the final completion of the project, by adding all these times, the sum of all the optimistic, some of the all most likely, some of the all the pessimistic times, in the best possible course, we may be able to finish it in 82 days. That is the most optimistic overall time estimate. The realistic, that is most likely time, is 107 days, and the pessimistic time estimate is 130 days. These are the 3 different time estimates as per Pert. Finally, coming to the advantages of Pert. The Pert forces managers to plan. It identifies the interdependencies between different tasks. It is possible to plan parallel activities to save time. Even if the activity is in parallel, we can identify that and do it parallelly so that the total time comes down. And we can compare different the schedules, different alternative paths by studying the Pert or by drawing the Pert in a different way. We can compare the different activities. And finally, it is a tool to monitor and control any project. Well, friends, we can summarize what we have done today. First, we discussed the concept of PPC, that is production planning and control. Then we discussed the major functions of PPC. Then we discussed 2 tools of production management, namely critical path method, CPM, and program evaluation review technique, Pert. We discussed their advantages and limitations. I hope you enjoyed the presentation.
Sir, what we'll do now is we'll go for the quiz. Can all of you hear me? If you can hear, just raise your hand. Okay, that's Mysore. That is Gulbarga. Well, we'll go for the quiz. So what I suggest is that only the team which I mentioned, please answer it through your chat window. So you can use the chat window to answer, to select your question. But only the team which I suggest, only that team has to select. Then the next chance will come to the next team. Well, friends, this is a quiz on what we have covered today. We'll start the quiz. This quiz is mainly on PPC, CPM, and Pert. Now you can see the 8 questions on the screen. In addition, there are 2 more. Screen ಬರ್ತಾ ಇಲ್ವಾ? Yeah. Well, friends, now the questions are on your screen. You have got the different questions. You have got 8 questions. The team can select your questions. I suggest CPC Mysore to select your question. You have got all 8 questions on the board. Please use the chat window to select your question. Number 1 to 8. Or you can unmute your mic and select the question. You can use the group chat, or you can even use the audio, unmute your mic and ask your question. One to 8. Or I'll say the question. You go for question 7. Okay. This is question 7. Ready? Yes, please, ready. This is a question. You have got which of the following is true with respect to quality control and inspection? Inspection is a subset of quality control. Quality control is a subset. Quality control and inspection are independent. They are mutually exclusive. There are 4 answers. Your answer, please. Either you can use the mic or you can use the chat window. Okay, you go for the. Let us check. Yes, here is the right answer. Congrats. Inspection is a subset of quality control. That means inspection is a small function. Quality control is a much broader function. Now, question number 7 is gone, but all the remaining questions are there. I request the Gulbarga, GPT Gulbarga to select their question. You can unmute your mic and you can directly use the mic also. Okay, I will select question number 3 for you. Question number 3. Please be ready. Once I open the question, the timer will start. Which of the following is not a time estimate in Pert? Optimistic time, pessimistic time, most likely time, regular time. Yes. Either use the chat window or unmute your mic and ask the question. You go for D. Let's check. D. Okay. Yes, you are right. There is nothing called a regular time. First 3 are the time estimates. D is not a time estimate. You are perfectly right. Now there are 3 questions remaining. Sorry, there are 5 questions remaining. We will go to SNM Mudabidre. Please select your question. either through audio or you can type in the chat window. You can go for 2, 4, 5, 6, and 8. Look, I'll select question number 4 for you. Please be ready. Here is your question. Which of the following statement is true with respect to CP and Pert? Only CPM is time oriented, only Pert is time oriented, both CPM and Pert are event oriented, both CPM and Pert are time oriented. When I say time oriented, I mean event oriented. Let's check. The right answer. Only Pert is time, that is event oriented. Now we have left with question 2, 5, 6, and 8. I request CPC Mysore to select your next question. Or I will directly pick the question. I'll go for question number 2. You go for question 5. Okay, very good. 5. Yes. Question 5 is on the screen. I'll open the question now, and your timer will start. You can see at the right at the bottom. 60-second timer. Yes. Which of the following statement is true with respect to CP and Pert? Event is start or end of a task. Event is an instantaneous point of time. Event does not consume resources.
Event does not consume
Actually, it has to be all of the above. I'm sorry. All of the above. You are right. The first A is right, B is right, C is right. So it has to be all of the above. But we are left with question number 2, 6, and 8. I request Gulbarga to select the next question. Gulbarga. You go for 6. Okay, good. Question number 6. Ready? Start. In case of destructive texting, we can go only for dash type of inspection, hand of inspection, sampling inspection, and
B.
yes, that's an easy one. Yes. For a sampling inspection in case of a destructive text. We are left with 2 more questions. Yes, and okay. Yes, I'll go for the question number 1. 2. I'm sorry. There is a small error. I'll reshare it. Yes, this is a question. Question number 2. Ready? When an order is first accommodated in dash schedule, master schedule, part schedule, composite schedule, all of them. Yes, you are right. The master schedule is right answer. That is where the part is first accommodated. You are left with only one more question, so you don't have to pick it. I will pick it. Any team can answer.
8.
Ready? The function which authorizes the start of production activities is called. Any team can type your answer. C. GPT Gulbarga. You are perfectly right. Congrats. The right answer. Now we are left with 2 bonus questions. This is open to all. Anybody can answer. The audience question 1. The output of inspection is always continuous, binary, progressive, regressive. Anybody can answer. Well, let me take the answer. The output of inspection on binary is going to be yes or no. Accepted or not accepted. Only 2. And we are coming to the last question. Here again, this is an audience question. Anybody can answer. The personal bias plays a major role in dash type of inspection: patrol inspection, central room inspection, sampling inspection, endurance inspection. Your answer, please.
Endurance inspection. Endurance.
Yes, GPT Gulbarga again, they go for A, and A is a perfectly right answer. Personal bias is an important role in sampling inspection. Yes, we have finished all the questions. Then ಬರ್ತಾ ಇದೆಯಲ್ಲ, share stop ಆಗಿದೆಯಲ್ಲ. Well, friends, that was the quiz. Now I am open. You can ask for any queries, any questions, your opinions, your feedback. Most welcome. Katra bantu.